Alright, hello everyone. Welcome to my channel. This is an educational channel that's focused on clarifying or bringing light to many theories of everything, and even eventually comparing and contrasting them. Mostly all-encompassing theories that you've probably never heard of or aren't familiar with, and doing a deep dive on them, kind of a comprehensive look at these various theories. Today is video number 287 that we have done on the reciprocal system of theory. And I think you'd be pretty hard-pressed to find any other channel doing in-depth work on the reciprocal system, if any. The reciprocal system of theory was originated by Dewey B. Larson back in the 20th century. He was an engineer who had a few epiphanies and worked them out to their logical conclusion, and ended up writing a lot of books on topics such as physics and chemistry and astronomy, but also on economics and some stuff on metaphysics, including biology and psychology and religion and ethics, philosophy, dream interpretation even. And spawned a few followers who have continued to write on the subject after Larson's death in 1990. And we're going to be covering one of those authors today. His name is Dr. KVK Nehru, coming from India. I think he's, or at least at sometime recently, was a professor at Hyderabad, I believe, but not exactly sure. But he's been following Larson's work for probably 40 years or more, and written extensively on the subject. Along with Dr. Bruce Perrett, he put together what is called RS2, the Reciprocal System 2, the re-evaluation of the reciprocal system, that took a few of Larson's points that he didn't quite have fully worked out, and revised them in a way that made more sense. We're going to look at an overview of Larson's theory from Dr. Nehru-Glimpses into a New Paradigm is the name of the article. First, I'll just give you a quick once-over. I think that Nehru sums up Larson's theory here in the paper, but just to give you some background before we start, Larson's basic theory that he summed up in two fundamental postulates that he wrote in the late 1950s is that we live in a universe of motion. The universe is not made out of matter, it's not made out of energy, it is made out of motion. And for Larson, motion was the relationship between space and time. Space and time are thereby reciprocals of one another, and you can think of motion as a fraction or a ratio, and with time or space as the numerator and space or time as the denominator. And he ran with it from there. His first fundamental postulate basically says that time or space both have, time and space both have an aspect that is three-dimensional, and they both have an aspect that is scalar motion, that is a motion that has a magnitude but has no particular direction, which you can envision as a clock. The clock is always getting later and later and later, or as dots on a balloon. If you blow up the dots, all of the dots, blow up the balloon, all of the dots are moving away from each other. So that's what Larson called clock time and clock space. Clock is always getting later and later. Space is always getting farther and farther and farther apart. But neither have any specific direction, or they're distributed over all directions. And then space and time both come in only discrete units. You need to have time and space in chunks. There's no continuity there. You either have a whole unit of space or time, or you don't have anything. So you either have one full unit or you have zero. And then you either have two full units or you still have one, and so on. So, and if you have exactly 1 unit of space in 1 unit of time, you have the speed of light. And so the speed of light in Larson's system is the null point, or the neutral point, or even the 0 point, the ether of this universe. And he calls that the natural reference system. So measurements are made from the speed of light. Whereas in legacy science, speed of light was seen to be the maximum speed of the universe. In Larson's system, speed of light is like the 0 point, or the midpoint of this universe. Half the universe is moving faster than the speed of light, half slower. And Larson calls those the cosmic sector and the material sector, respectively. And they are basically reciprocals of one another. You just have to reverse the roles of space and time. So in the material sector, you have coordinate three-dimensional space, and you have clock time. And in the cosmic sector, you have coordinate three-dimensional time, and you have clock space. Space is always getting farther and farther apart. And then he goes from there and takes in the second postulate, which basically says that the universe conforms to the relations of ordinary commutative mathematics. Its magnitudes are absolute, and its geometry is Euclidean. There's been some contestation having to do with the Euclidean geometry that we will get into at another date. But those two postulates he took, and then he developed his own theoretical universe from that through a process of deduction. And I went over that in about 15 videos way back about eight months ago. If you want to check those out, the outline of the deductive development of the reciprocal system. Okay, so we'll just go with that, and we'll start this article here from Dr. Nehru, Glimpses into a New Paradigm. For centuries on, mankind has held implicitly the view that we live in a universe of matter, contained in space and time. All scientific theories hitherto have been built on this paradigm. Now, Larson introduces the new paradigm that motion is the basic and sole constituent of the physical universe, and space-time is the content, not the container, of the universe. We review in this article some of the highlights of his theory, the reciprocal system, which he develops from the new paradigm. Introduction. The objective of this article is to introduce to the physical theory being called the reciprocal system. Its originator, Dewey B. Larson, starting from two postulates as regarding the nature of the basic constituents of the physical universe and the mathematics applicable thereto, builds a cogent theoretical structure that lays claim to a general theory. As it is impossible to outline the whole theory in the short space of an article, attempt has been made to present only those salient features that do not require lengthy explanation and have a broad enough scope to enable the interested reader to appreciate its potentialities. More esoteric features of the theory have been intentionally omitted from this preliminary treatment. They are, of course, available in the published works of Larson. This section is called The Conceptual Roadblock. The view that the physical universe is made up of basic units of matter, embedded in a framework of space and time, has been held by the common man and the scientist/philosopher for over the entire period of recorded history. Every new century has brought new and revolutionary ideas about the universe that shook and changed our earlier views, but the concept of matter contained in a space-time background has remained unquestioned. Larson finds that it is this concept, which we shall call the concept of the universe of matter, that stood in the way of the development of a truly general physical theory, one that explains all domains of physical facts, from the atomic to the astronomical, from the same set of fundamental premises. He has carried out the needed review of the concepts of space and time and finds that the introduction of the new paradigm, that the fundamental and sole constituent of the physical universe is motion, leads us to the understanding of all the physical phenomena and makes possible the construction of the long sought after general theory. To be sure, there have been earlier thinkers who attempted to build a general theory basing on motion as the fundamental constituent. Larson points out that the lack of success in all earlier attempts was due to the fact that these thinkers failed to realize the crucial point that in a universe based on motion, which is a relation of space and time cannot have an independent existence by definition, that they cannot be regarded as a background or container for themselves. No matter whatever conceptual reforms these thinkers have introduced into physical theory, they are they all alike continued to subscribe to the container view of space and time and block themselves from true progress. This section is called Space, Time, and Progression. The first of the two fundamental postulates of the reciprocal system from which Larson derives every aspect of the physical universe is, quote, "The physical universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time." Larson considers speed, which is the relation of space and time, space over time, as the measure of motion, and points out that a unit of speed is the minimum quantity that can exist in the universe of motion, since fractional units are not permitted by the postulate of his theory. Since 1 unit of speed is the minimum quantity admissible, both space and time have to be quantized. Unit speed must therefore be the ratio of a unit of space to a unit of time, each of which is the minimum possible quantity. Certain corollaries follow. Corollary 1. Firstly, we see that space and time are reciprocally related to speed. That doubling the space with constant time, for example, has the same effect on speed as halving the time at constant space. As a recognition of the far-reaching significance of this reciprocal relation holds for the explanation of all physical facts, Larson names his theoretical structure the reciprocal system of theory. Corollary 2. At unit level, not only 1 unit of space is like all other units of space, but also a unit of space is equivalent to a unit of time. Larson postulates a total uniformity in the properties of space and of time, except for the fact that they are reciprocal aspects of motion. Thus, he concludes that time is three-dimensional as space is, and that space also progresses like time does. At this juncture, it may be pointed out that in order to understand or evaluate the new ideas engendered by the new paradigm, namely that the physical universe is a universe composed of units of motion, speed, it is necessary to view them in their new context. On the other hand, the most frequent mistake committed by the novice is to view the new concepts from the habituated viewpoint of the previous paradigm, that the universe is a universe of matter embedded in a framework of space and time. Such an attempt leads one often to seemingly absurd, impossible, or incredulous conclusions. To avoid slipping back involuntarily into the old and inadmissible frame of mind while evaluating the reciprocal system of theory is one of the most difficult tasks that a critic has to accomplish constantly. Now, it is important to recognize that there is absolutely nothing space-like in the three dimensions of time. They are entirely temporal parameters. The common belief that time is one-dimensional is an unwarranted conclusion drawn from the fact that time enters our experience as a scalar quantity. The real reason why time appears as a scalar quantity in the equations of motion lies in the fact that no matter how many dimensions of time do exist, they have nothing to do with directions in space. The idea that space progresses like time, does, might look more weird than the idea of multidimensional time. Our immediate experience is that of stationary space, but history has repeatedly shown that our immediate experience of space has always proved to be a bad guide to understanding the true nature of the universe. We first thought that the Earth is flat. Then we made the mistake of thinking our Earth to be the center of the universe and ended up in the maze of epicycles. Larson draws our attention to the fact that the increased scope of our scientific observations has brought us to the point where too many epicycles have once again been accumulated in the field of science in the form of unresolved old questions, fresh new puzzles, and ever-increasing complexity of physical theory. He questions whether our anthropocentric view of space is not the culprit once again that is barring the progress. He points out that our experience of space is stationary, is valid only locally, that is, in the context of a gravitationally bound system. The true nature of space is to progress, to expand ceaselessly outward. Wherever gravitation, an inward motion, becomes negligible, weakened by distance, the inherent progression of space becomes apparent. The observed recession of the distant galactic systems stems directly from this space progression, not from any hypothetical Big Bang. In fact, the observed Hubble's law could be derived from the postulates of the reciprocal system. Since a universe of motion cannot exist without the existence of motion, the most primitive condition of the universe is the steady progression of space coupled with the progression of time. In other words, a motion at unit speed. Beginners usually encounter here the difficulty of imagining the existence of motion without it being the motion of anything. but a little reflection should show that in a universe of motion, the most fundamental constituent is motion, and all things are derivatives of motion. Since every space unit is like every other space unit, and every unit of time is like every other unit of time, such a condition appears to our view as a featureless uniformity in which nothing is happening and constitutes the null background. Thus, unit speed and not zero speed turns out to be nature's starting point. Larson refers to this background space-time progression as the natural reference frame and identifies the unit speed with the speed of light, c. The section is called Emergence of Physical Phenomena. By virtue of the fact that either the space unit or the time unit could progress inward rather than outward, as it does in the case of the space-time progression, speeds other than unity become possible. Larson points out that it is these deviations or displacements from the unit speed that constitute observable phenomena, namely radiation, gravitation, electricity, magnetism, and all the rest. These are autonomous, independent motions in contradistinction to the ever-present background progression. This gives rise to two possibilities. Suppose a number of reversals occur in the space-time, k number of reversals occur in the space-time component. And suppose the unit speed of space-time progression contains n space units per n time units, n over n equals 1. Such a situation produces less than unit speeds, n minus k over n. Since such a motion detaches itself from the space-time progression in its spatial aspect, we find it to be a motion in space. The second possibility is that the reversals occur in the time component of the motion. This results in greater than unit speeds, n over n minus k. In this second case, it is the time component which gets detached from the background progression, and we note that it constitutes what might be termed as a motion in time, which is not to be confused with time travel. This is the reason why unit speed, speed of light, is the upper limit for motion in space. It does not mean, as concluded in relativity, that speeds greater than the speed of light are impossible in the physical universe. It only means that such speeds do not manifest in our conventional stationary reference frame of three-dimensional space as displacements in space. These greater than unit speeds, namely the motion in time, can be represented truly only in a stationary reference frame of three-dimensional time. Our state of knowledge so far has disposed us to assume tacitly that motion means motion in space. The possibility of motion in time has never been imagined, much less investigated. Such motion, though, cannot be truly represented in the conventional spatial reference frame, has nevertheless some observable features by virtue of the inverse relationship between space and time. For example, in a supernova explosion, if sufficient energy is available, Larson points out that some of the constituent matter of the star gets propelled to greater than unit speeds. The less than unit speed component manifests as a cloud expanding in space. On the other hand, the greater than unit speed component manifests as a cloud expanding in time, since it is a motion in time. In view of the reciprocal relation between space and time referred to above, this expansion in time manifests to us as contraction in space, and we observe this component as a superdense and compact star. Thus, we have the red giant, white dwarf combination so frequently found as supernova products. Larson's theoretical investigations show that the same concept of motion in time can explain every other type of superdense astronomical phenomena, not just the white dwarfs. He shows that as age advances, the central regions of massive galaxies keep on accumulating motion in time. Since greater than unit speeds do not involve movement in space, this matter does not leak out. When enough energy accumulates, it results in a stupendous explosion in which the central parts of a galaxy gets ejected and is found as a super dense star system, which of course is observed as a quasar. All the strange and unconventional characteristics of quasars, like their high density, large redshift, significant luminosity, jet structure, peculiar radiation structure, evolution, can be deduced from the theory. And I will also note that it has been deduced by the theory. Larson predicted the existence of quasars way back in the late 1950s before they were discovered observationally by a few years. So, Larson's theory brings the receipts. He's able to make predictions about things that were heretofore unacknowledged, and eventually was proven to be correct. Not only did he predict the existence of quasars, but he predicted them in great detail. I believe like 14 different qualities of them. Okay, back to Nehru. We have seen that the null condition of the universe of motion is the unit speed, and that the displacement from this condition takes the form of either less than unit speed, s over t, or greater than unit speed, the latter being equivalent to less than unit inverse speed, t over s. Larson identifies this displaced speed with radiation and the speed displacement with its frequency. While the photon gets detached from the background space-time progression in the dimension of the oscillation, it does not have any independent motion in the dimension of space perpendicular to the dimension in which the vibratory motion occurs. Thus, the photon is permanently situated in the space unit of the space-time progression in which it is created. But from the context of the stationary spatial reference frame, any location of the space-time progression appears to progress outward away at unit speed. Thus, while actually the photon is stationary in the natural reference frame, ostensibly it appears to move away at unit speed. Incidentally, we might note that when in a single process a photon pair happens to be created, while the individual photons seemingly appear to fly off in space in opposite directions, they continue to be connected in time. This results in a correlation between them that is not representable in three-dimensional space. And that's the EPR paradox. Okay, we'll try to get through the rest of this section here. Once photons are available, the possibility of a compound motion appears wherein the photon could be subjected to a rotational displacement in 2 dimensions, covering all 3 dimensions of space. Larson identifies such units of compound motion with atoms of matter. Because of the 2 facts that the maximum possible speed is unity and that the background space-time progression is already taking place at that speed in the outward or away from each other direction, all autonomous or independent motions have to take place in the inward toward each other direction only. Thus, the units of rotational displacement start moving in the inward direction, reversing the pattern of space-time progression. Larson identifies this inward motion with gravitation. We now see that there is no propagation involved in gravitation, nor it can be screened off, nor can it be screened off. It is the inherent motion of each atom toward every other atom. In fact, toward every other location of the space-time progression, whether or not occupied by an atom. The non-existence of propagation time and the seeming action at a distance both owe their origin to the above fact. Theoretical analysis reveals that elements with atomic numbers 1 through 117 can all exist in young matter. In old matter, however, elements with higher atomic numbers start turning radioactive by a process identified by Larson. Okay, we're going to leave it there for right now. The next section here is called the regions of the physical universe. And we will start with that tomorrow on the same channel. And thank you for tuning in. Have a pleasant